Namaste everyone, welcome to my channel. In today's video we are going to be revising all about volcanoes and volcanic landform. So let's get started. So what is a volcano? It is basically a rupture in the crust of the planetary mass or an object such as Earth. So basically it can happen on other planets as well. That allows hot lava. Lava is basically when the magma comes up to surface, volcanic ash and gases to escape from the magma chamber. So like I said, magma is when it is inside the surface. So when the hot lava comes out, that's when it is called a volcano. And mostly they are found, often they are found where tectonic plates are diverging and converging, which we already revised in the previous video. So we know mostly how all the volcanoes are formed except from the hotspot volcano, which we will be doing today. So there are two types of volcanic eruptions. One is the central kind of eruption, when the volcanic eruption happens from a central vent or a pipe. So here this is the key word, that there's a vent. In such kind of an eruption there is high pressure because the path to escape for the lava is very narrow. Compared to when there is a fissure eruption. So since the path is narrow, there's going to be more lava trying to escape from the smaller path. Also because of that there's high pressure, and since there's high pressure there's a chance that it could even, the lava could even cool down before it reaches the surface. So there could be a blockage, and if there's a blockage, the pressure is going to increase any which ways. And again, because of that, such central eruption kind of volcanoes are the most kinds which are more explosive and which cause heavy destruction, and they're also the cause of earthquake. These centrally erupted volcanoes are the ones that form cones or volcanic mountains, and they release lesser lava as compared to the fissure eruption. These central eruption volcanoes are found mostly at the convergent plate boundaries, or they are found at the hotspots. But mostly, like the ones that are found at the convergent plate boundaries, are always centrally erupted volcanoes. Then comes the fissure eruption. Fissure eruption happens when there is divergence, so they are found at divergent plate boundaries. Basically, they are constructive margin. So the way we can remember is that, since the central eruption happens at destructive plate boundaries, it creates explosion and destruction and earthquake. Whereas in the fissure eruption, it happens at constructive margins because it is at the divergent plate boundaries. That's why it is responsible for construction of oceanic landforms in form of mid-oceanic ridges. So it does not cause any explosion, and it has very less destruction. There's very less chance of earthquake, but because there is less pressure since it's divergence, a lot of lava is released in this kind of volcano, and because of that only it is able to form such huge oceanic flows, because a lot of lava is going to be required to form such landform. So there are two types of lava, acidic and basic. In the acidic lava there's 70 to 80% of silica, whereas in the basic there's less silica as compared to the acidic. It has more metallic minerals. The acidic lava is highly viscous. Because of that it is quite thick and it flows very slowly, and that's why it has even less flow. That's why it has more chances of blockage, and creates more pressure, and that's why it is more explosive generally, and it mostly happens in the central eruption. And the fact that it happens mainly during the converging plate boundaries, since it cannot flow much and it is highly viscous, it gets accumulated at one place, on top of another. Because of that it forms very high mountains. Whereas in the basic lava it has more metallic minerals, and so it has less silica, which is why it is its viscosity is very less, and so it flows much more, and since it flows much more its height is quite less. Also to know that we've already observed that the ocean floor is made up of lava which flows a lot, because that's the only way such huge oceans would have formed. And since it has more flow, we can easily did arrive to the conclusion that that means that it could be a basic form of lava, basic lava. And in the basic lava, since there are more metallic minerals, it is going to be heavier, which is why it is considered that oceanic plate is heavier than the continental plate, since continental plate has more silica and oceanic plate has more minerals, metallic minerals. And since there is metallic mineral, it's going to be darker in color. The rock is going to be darker in color, and such rock is often one of the kind of rocks which is basic lava, which is made out of basic lava, is called basalt. Such darker rock is the reason why we have black soil, especially in the Deccan area. Now we move on to understanding some of the basic terminologies when it comes to a volcano. The first thing that we need to understand is crater. Crater is basically when it's basically the mouth from where the volcanoes erupt. So on the peak of the mountain, sometimes what happens is when the volcanic eruption happens, the peak in itself, the cone, the tip basically blows off to give space for volcano, or to give space for the lava to come out. And such a hole formed on the top of the mountain, as to kind of give space for the lava, is called crater. When the crater is bigger, sometimes after the eruption it happens, after a few years again the second eruption happens, which is even more explosive, and it kind of blows almost the entire mountain top off, and it is very large in size. That kind of formation is called caldera instead of crater. It is much bigger than crater, but it is formed in a similar manner. The next terminology we need to understand is volcanic cone. It is basically such mountain-like structure, the conical shape formed because of lava, and this is called volcanic cone. The next is volcanic plug. So this used to be someday, inside. It used to be. It's kind of like an intrusive landform. So what happens is when there is a volcanic cone and lava is trying to come out, but it could be the fact that it is an acidic lava, which is why it is moving slowly. And before it reached the surface, it basically was filled up, inside the mouth itself, but it never left the surface, and it stayed inside, and eventually it cooled down right there. Years later, when after the entire mountain peak or that landform is eroded, this is the only structure that is left, which was basically the lava inside the mouth, but it never left. So this is called volcanic plug. Next thing to understand is Tephra. Tephra is basically the fragmented rock that leaves during the volcanic eruption, because it's a blast, it's an eruption. Small tiny particles and the fragmented rocks, it leaves from there, and basically collected together they might look something like this, but mostly it kind of leaves just in this manner. So this is Tephra. Along with Tephra, we need to understand one more term, which is Cinder. So when such fragmented rocks, along with that there is some ash and there is some dust particles. Along with that there is also some of the liquid lava which has gone up in the air, but when it is falling back down it kind of solidifies. So all of that mixed together, that smoky material that mixes together, that fine material that comes out, that is called cinder. Next is Lahar or pyroclastic flow. Basically when the lava is coming out, and at that time it happens that there is a rainfall, then the lava is going to get mixed with such water, and when it flows, it kind of flows in form of such muddy flow, and this is called pyroclastic flow or Lahar. Pyroclastic flow is actually very hot. It has very high temperature, even though it is mixed with water, because it is after all lava. And when it comes out like this, it actually ends up drying up all the plants or all the life form that happens on its path. So this is the pyroclastic flow. Since it is very hot, that's why it is called pyroclastic. Next, we try to understand the types of volcanoes. So we can distinguish the types of volcanoes on the basis of two things. First is how it is erupted. So as we already discussed, central eruption and fissure eruption, and then periodicity of its eruption, which is active, dormant, and extinct. Although certain, many geographers believe that there is no concept like an extinct volcano, because it could be dormant, but you can never say that it is never going to erupt again, because you never know what is happening in the interior of the earth. Then we move on to volcanic landforms. So there are two types of volcanic landforms. First is the extrusive landforms and the second is the intrusive landforms. So let us go with the extrusive landforms first. In extrusive landforms, if there's a central eruption, the first landform that we see is composite cone. Composite cone is also called stratocone. Basically, when the lava comes out, it kind of forms such a layer of lava. But when there is a central eruption, there is high chances that it is going to be a little explosive. And when it is explosive, cinder comes out, the ashes and the fragmented materials basically. It kind of goes up in form of smoke, but eventually with gravity it is going to settle down on top of this lava landform, basically the landform that is formed, the cone that is formed because of lava. So it is going to settle down and it is going to have a layer of ash. Again, when the second time such a eruption happens, that time again it is going to have another layer on top of that ash in form of lava. But again, eventually when the dust and the smoke and the ash settles down, it's again going to form another layer. So such layers of ash and lava is basically what forms the composite cone. Now we missed out on one fact earlier. Why the convergent plate boundaries are generally give out acidic lava. So when the plate, when there are two plates and the plate is converging and one of the plate goes down, right here is where it starts melting. But even if it is an ocean floor, the melted plate would be basaltic, but that basaltic material, which is very highly fluid, is going to keep moving on along with the rest of the magma which is in the magma chamber. But here there is pressure, and at that time only the acidic bit will find it difficult to move, which is why that bit is going to settle here and that is going to come out in form of acidic lava. So that is the reason that whenever there is convergence, and mostly in all of the central eruptions apart from the hotspots, acidic lava is going to come out. Anyway, let's move to the next landform. The next landform is the shield cone. So this is when the hotspot phenomena happens. So this is basically centrally erupted volcano, but it has basic lava flowing, which is why it is not going to accumulate and have a huge height, but it is going to spread. But since it's still going to kind of form some height because there is some accumulation, it is going to form look like a shield, and which is why it is called shield cone. The next landform is parasite cones. So when there is the formation of the composite cones, at that time on the side there could be such parasite cones forming because when there is an explosive volcano, there's a chance that there's going to be earthquakes, and because of earthquakes there could be cracks in the path of in the volcanic pipe, and because of that the lava might get more than one path to try and flow out, and since the pressure is high, it is going to form more paths. And if it is forming more paths on top of the composite cone or the main landform, there is going to be formation of such secondary pipes, and because of that such secondary smaller cones, and such cones are basically called parasite cones because these cones are basically feeding off the main pipe. It doesn't have its own pipe, but it is feeding off the main pipe by forming, by stealing some of the lava towards itself. These are parasite cones. The next landform is the cinder cones. As I had explained earlier, what was cinder? Cinder is basically the volcanic ash and the tephra and all of that, small fragmented material that leaves the volcanic eruption, and it kind of stays above because it is quite light. But then eventually, after the eruption is over and the lava cools down, in the influence of gravity, it comes down and it settles on top of the volcanic cone, and such a cone which has a thick layer of cinder is called a cinder cone. So it looks something like this. The next landform is so these were the central eruption landforms. Then we move on to the fissure eruption landforms. So as such, we've already done the fissure eruption landforms, but I'm just going to quickly go through them. One of them is the rift, because it happens during the divergence. So rift is something that generally forms. Next is the mid-oceanic ridges. That also was something that we already did. So due to fissure eruption, these two landforms are formed. Also, there's a formation of plateau. So basically, because of the fissure on the continent, what happens is that the plates move away from one another, the lava comes out, and it spreads in a large distance. And because of that, that region is slightly heighted than the plains. So it has a little more height, but it is not as high as a mountain or anything. So such landforms are called plateaus. So now we move on to the intrusive landforms. Sometimes certain landforms happen in the interior itself, because before the lava could appear on the surface, it basically cooled down. So it's still magma, but it cooled down, and with years of erosion, the top layers, the sedimentary rock on top of such cooled lava kind of erodes away, and such landforms are exposed. So these are those landforms. Now, when the volcano is erupting, apart from the central pipe, we already understood that there could be other paths that lava may find, and it may settle there, and it may come out or it may not come out. If it does come out, it might form a parasitic cone, but if it does not come out, it basically forms such intrusive landforms. So let's look at them one by one. The first intrusive landform is sill. Sill is basically when there is such horizontal settling of lava. So this is sill right here, if you can see here. This is sill. Then there is dike, when there is a little vertical or a kind of settlement of lava. So it is basically trying to go up, but it has not quite reached up yet. That is what is dike. So sill is generally considered to be parallel to the sedimentary rock, or all the existing plain or the sedimentary rock that is there, whereas dike is formed which is slightly perpendicular to it. So that is the difference between sill and dike. Then if there is such saucer shaped or concave form of landform of lava, this kind of landform is called lopolith, and if it is like this, which is convex, it is called laccolith. So lopolith and laccolith. And then there is anticlines and synclines. If there is anticlines and synclines, it is called phacoliths. So how Sir made us remember was that if we phaco the ball is going to go anticline and syncline also, and that's how we remember phacoliths. So that is phacoliths. And the last landform to remember is the batholith. Batholith is basically found at a much more depth than all these other landforms. It is it is kind of like an accumulated lava, which is kind of more in amount than the other landforms. And this batholith is generally dome-shaped structure, and it is a little harder than the other rocks, because this structure is, since it is at the depth, it must have cooled down a little slow, and because of that it has become very hard. It has gotten a chance to crystallize much more. So that is batholith. So now we move on to the hotspots. It is believed that in the interior of the earth there are some fixed areas from where very high temperature exists, and convectional current rises up from there, and it basically comes out like a plume. Is basically, sometimes we've seen in a glass of water, there is from one place some bubbles keep coming out. So similarly, in the earth's interior there is one place from where, like a bubble of lava which is very hot, which is why, because of the convection, it keeps coming out. And that lava is so hot, it is much more hotter than the other lavas. It is so hot that it has a capacity to melt away the lithosphere. So when it reaches up and it kind of meets the it meets the surface of the lithosphere, it melts from there and it kind of comes out. Now these places are fixed in the earth. So if the lithospheric plate moves on top of such areas, it is going to come in the influence of a hotspot. Since the temperature of such a convection current is it is so high, it is believed that such high temperature can be mostly found in the mantle core area, and it is believed that such lava is basically rising from there. Such magma is rising from near the mantle core area, and it comes out in form of a plume, which is why it is called mantle plume. These are few more concepts associated with volcanism. So sometimes there is groundwater which gets heated up because of coming in close contact with the magma chamber. Now such hot water, when it gets heated up, it is going to turn into vapor and steam, and it is going to come out of the surface of the earth in different forms. So when such water, when it is coming out and it finds such spaces in the rocks, the steam gets accumulated in such spaces. And what happens, since the steam is getting accumulated, it gets a chance to gather and create more pressure. So after a while, when the pressure is unmanageable, it bursts out with an explosion, and it releases water and steam, and such a phenomena is called geyser. One of them, right here, if we see, this is how it looks like. This is the old faithful geyser of Yellowstone National Park, and it is called Old Faithful Geyser because it erupts every 60-61 minutes. The next concept is that of hot spring. Hot spring is when the water does not get a chance to get trapped somewhere else, which is why it doesn't have a chance to form steam, and it just keeps coming up basically. Such hot water gets basically accumulated in like a small hole kind of a thing, lake kind of a structure, and it is called hot spring. So it has liquid hot water. It basically looks something like this. These are found actually in India as well. There are many of them in Uttarakhand and Himachal Pradesh region. So those are the hot springs. And the last one is fumarole. Fumarole is when even water doesn't come out. Maybe it might not have such space for water to get accumulated, and it doesn't actually have the space to create pressure also. So basically what just happens is that the heated up water comes out in form of fumes and steams basically. So it looks something like this. These fumaroles are found in the Katmai near the Katmai volcano in the Alaska mountains. They are very common there, and in fact there are so many fumaroles over there that it is called 10,000 smokes basically. Anyway, so that was my video for today. I hope you found it useful. If you did, please leave a thumbs up and do leave a comment because it really encourages me as well. And if you have not subscribed to my channel yet, please subscribe. Thank you so much for watching this video.